Welcome to the Copperfield Electric Podcast. Today, we are undertaking a pretty critical deep dive. We're looking to an innovation that really promises to fundamentally flip the script on electric vehicles. Forget thinking of your EV as just, consuming energy. Thanks to new bi-directional technology, it's about to become a powerful distributed source of energy. And we're zeroing in specifically on curbside vehicle-to-grid or V2G EV charging. We want to examine the massive implications it holds right here for us in Orange County, California.
Yeah, this is such a timely and, frankly, vital topic. Our mission today really is to unpack why V2G isn't just some interesting concept, but actually a cornerstone of California's energy future. The state's committed, as you know, to 100% clean electricity by 2045. And look, relying solely on massive centralized power plants, well, that's not going to get us there. This technology effectively transforms millions of parked cars into essential decentralized energy storage units, which is absolutely crucial for grid stability, especially in our dense urban centers.
Right. And the fact that this has real backing, a substantial $1.1 million grant from the California Energy Commission, that shows this isn't science fiction anymore. This is a, shovel-ready infrastructure project happening right now. So we'll start by maybe defining the V2G mechanism, talk about the economics for you, the EV owner. Then we'll move into the critical role that local experts like our team here at Copperfield Electric must play in actually building this future out.
Okay, let's really unpack this shift. It's pretty fundamental. For the average EV driver, right, charging is simple. You plug it in, energy flows from the grid into the car. That's it. So what's the mechanical or, chemical innovation that lets V2G suddenly reverse that flow?
That's a great question. It's actually less about the battery chemistry itself. It's more about the hardware and the software management system around it. The core innovation lies in the bidirectional charging unit. This unit contains an inverter, and that's key. It can take the DC power stored in the battery and convert it back into grid-compatible AC power. So this allows the EV to actively, push power back onto the utility lines. Think of it like opening a two-way valve instead of just a one-way faucet.
A two-way valve. Okay. So connecting this to the bigger picture then, why is this two-way movement suddenly so valuable now?
Well, it addresses the single biggest challenge we face with intermittent renewable energy. And that's storage. Solar energy peaks midday, right? But utility demand, it peaks later, maybe 5 p.m. to 9 p.m. That's when everyone gets home, turns on the air conditioning, starts cooking. EVs can absorb that surplus solar power during the day, essentially load shifting the energy vote, and then hours later discharge it back during those critical peak demand windows. This really maximizes how we use clean energy that's already generated.
That sounds, fantastic for the grid. But I can almost hear listeners asking that obvious, maybe skeptical question. Okay, if I sell power back to the grid, does that void my expensive battery warranty? Or does it, accelerate battery degradation,
Right.
wear it out faster?
That's a really important point and definitely a common concern. The industry has had to address this head on. Actually, research suggests that VDG cycles, especially when they're optimized by smart software, can have a neutral or sometimes maybe even a slightly beneficial effect on battery health compared to just standard driving cycles. The key is smart charging and discharging. The system only draws power within very specific optimal limits set by the manufacturer and the aggregator managing it. It definitely won't drain your battery past a minimum charge level you set, ensuring your commute isn't compromised. And it very carefully controls the current flow to minimize any stress on the battery cells.
Okay, so the system's actively protecting the battery, the asset, while still leveraging it. Makes sense. What about the money side for the driver here in Orange County? What's the actual potential for, financial benefit? Is it real?
What's fascinating here is the potential for profit.
Yeah.
Instead of just paying to charge your car, you could actually earn money back.
Yeah.
You're essentially turning your parked car into a contracted asset for the utility or an aggregator working with the utility. Now, the revenue, it varies wildly, depends on local market rates, how much you choose to participate, that sort of thing. But estimates suggest an active V2G participant in California could potentially offset most of their annual charging costs, maybe even earn, say, a few $100s annually, simply by allowing their car to discharge power for maybe an hour or two during those highest demand, highest price peak windows. That fundamentally changes the whole economic value proposition of owning an EV.
Right, okay. But to make the system work across potentially millions of cars and chargers, you need absolute technical standardization. And you definitely need rigorous security. We mentioned that $1.1 million grant supports this development. What's the actual enabling technology? The thing that ensures this two-way communication and power flow is managed safely, securely, across all the different vehicle types.
This is where the J3068 active cable development becomes really critical. It's being worked on in partnership with places like the University of Delaware. The cable itself is an untethered solution, meaning it's not like permanently attached to the charger station itself. You bring your cable. And it's the intelligence embedded within this cable that matters most.
So it's way more than just copper wire then.
Oh, absolutely. Much more. The electronics embedded inside the cable handle the pretty sophisticated communication protocols needed for that bidirectional flow. We have competing global standards right now, mainly CCS and SHADE-MO, used by different car manufacturers. This active cable technology is really key to standardizing that communication layer. It allows the charging station to verify the car, the owner, check the transaction limits, ensure the power quality is right before any energy actually reverses direction.
Okay, that addresses the standardization piece. But what about security and payment? That seems crucial too. If my car is basically acting like a mini utility substation on the curb, the security risk has got to be pretty high, right?
Security is absolutely paramount, yes. And it's handled through secure digital transaction protocols embedded right in that J3068 system. It acts like a kind of digital handshake and a financial ledger, all in one. Before any power flows back, the system authenticates both the EV and the charger securely. This makes sure that energy transactions are tracked precisely, like who sold how much power, at what rate, and exactly when. That allows the utility or the aggregator to credit the EV owner accurately. And importantly, it prevents unauthorized access or energy theft. I mean, without this secure, traceable communication link, the entire economic model it falls apart. It's the invisible infrastructure really supporting the visible charging port you plug into.
Okay, here's where this technology gets really interesting locally. It starts addressing a huge social challenge right here in Orange County. Why is Curbside V2G such a breakthrough specifically for this region? Why not just, push to install these in every single garage?
Well, the key problem that Curbside V2G solves, equitable access, especially in dense urban environments. Orange County isn't just sprawling single-family homes with two-car garages anymore. Not entirely. We have high-density cities where many, many residents live in multifamily housing, apartments, or maybe mixed-use developments. And these drivers often rely on street parking or maybe shared public lots. They don't have a private spot. So if we want the transition to EVs to actually succeed for everyone and meet the state's mandate, we absolutely have to provide accessible, affordable, and potentially profitable charging options right there on the sidewalks where people park.
And the source material we looked at specifically highlights cities dealing with these exact urban density challenges. Places like Santa Ana, Anaheim, and Fullerton. These are areas where bringing public, bi-directional chargers right to the curbside. Well, it removes a massive barrier for people wanting to adopt EVs.
Precisely. And remember, that state grant we mentioned specifically emphasizes equity. That's a key pillar. Think about it. If you live in an accessory dwelling unit, an ADU in someone's backyard, or maybe an older apartment building with no dedicated parking stalls, your ability to participate in this whole energy transition has historically been pretty much blocked. This curbside solution really helps level the playing field. And what's more, by allowing these EV owners in those situations to participate in energy markets. They're not just consumers anymore. They become active contributors to the local grid, and they can potentially receive financial benefits that help offset the cost of owning the vehicle in the first place.
Okay, but how does that participation actually work in practice? If I'm an EV owner living in, say, Santa Ana, do I suddenly have to become some kind of electricity day trader watching the market?
Oh, definitely not. No. The complexity is handled behind the scenes by something called an aggregator. Think of the aggregator as a highly sophisticated software platform. It manages thousands of these V2G-capable EVs simultaneously. It communicates directly with the utility grid to figure out when demand is highest and, crucially, when electricity prices are spiking. Then, it sends signals out to your V2G charger, basically asking permission to discharge a small amount of power back to the grid for a short period, maybe, like 5:30 p.m. to 6:30 p.m. on a hot day. But you, the EV owner, you set your preferences beforehand. Like, never discharge my battery below 50% charge, for example. And the aggregator handles all the real-time financial transactions, crediting your account automatically. That automation piece is absolutely what makes the whole system scalable and user-friendly.
Okay, let's zoom out again for a second. If Orange County successfully deploys, I don't know, hundreds or even thousands of these curbside V2G units, what tangible difference does that actually make for the entire power system? It sounds like it's about more than just convenience. It's about reducing strain.
Yeah, this raises the critical question of scale, doesn't it? When you aggregate the storage capacity of thousands, maybe tens of thousands, of parked EV batteries, you effectively create what's essentially a massive distributed virtual power plant. So how does this virtual plant help stabilize a grid that's already stressed by rapid population growth, and especially by these climate change-driven heat waves we keep seeing?
Can you give us some concrete examples, like hard numbers or specific comparisons?
Sure, the benefits are really multifaceted, and they are quantifiable. First, think about offsetting peak demand. Utilities often have to fire up these expensive and usually quite dirty natural gas peaker plants. They only run for maybe a few hours during extreme heat events, but they cost a fortune and pollute. Well, if a few thousand EVs can discharge power during that same window instead, you might avoid the need for that polluting peaker plant entirely. That's huge. Second, grid resilience. During unexpected outages, maybe from storms or other events, V2G cars could provide localized backup power. They could support critical infrastructure like traffic lights, or even help power neighborhood microgrids until the main grid is restored.
So this localized generation using cars already parked there, it reduces the need for those really costly, large-scale infrastructure upgrades. That must save Orange County residents money in the long run, right, on their utility bills.
It absolutely should, yes. When the utility doesn't have to invest billions in building new massive transmission lines or entirely new power plants just to handle those brief, maybe only annual peak demand spikes, those savings should eventually be passed down to consumers in rates. Utilizing existing assets, these EV batteries already owned by residents, is arguably the most cost-effective way to build a more resilient, clean grid for the future. It really transforms energy infrastructure from just a centralized top-down system into something more robust, localized, almost like a community-based network.
Now, handling this kind of complex grid integration, that takes more than just smart software, right?
Yeah.
You need licensed, experienced boots on the ground, electricians who really understand bi-directional, current local building codes here in Orange County, and the precise installation requirements for these sophisticated new charging stations, not just plugging something in.
That's exactly right. That's the crucial transition point from concept to reality. The rollout of these specialized V2G chargers, it creates significant opportunities for local licensed electricians and contractors right here in Orange County. But it also requires them to undertake specialized upskilling. They need training in bi-directional systems, smart metering, grid integration protocols, things that go far beyond a standard residential EV charger installation they might do today.
And this brings us directly to Copperfield Electric. As, your trusted 24-hour electrician here in Orange County, their core identity seems to align perfectly with this kind of forward-thinking infrastructure push.
Definitely. As a family-owned business, they have deep roots in the community. They're committed to comprehensive service, including, importantly, 24/7 emergency electrical services. That commitment to local resilience is really essential when you're dealing with critical infrastructure like V2G charging.
Yeah, and their expertise already covers the full range of modern electrical needs people have. Things like panel upgrades, which are often necessary to support these higher electrical loads from chargers. Electrical installation for new construction, including all those accessory dwelling units, the ADUs popping up. Plus, commercial EV installations, too. They aren't exactly new to the EV infrastructure game. It seems like they're just evolving right along with it.
That's how Copperfield Electric views it, yes.
Yeah.
This V2G project isn't some distant policy goal for them. It's the immediate future unfolding now. They're really focused on ensuring they have the technical capability and the expertise to install these advanced bidirectional chargers safely, correctly, and efficiently, basically paving the way for a more resilient and, importantly, equitable energy future across the whole region.
And we know they already serve the breadth of Orange County, which makes them such a crucial partner in actually rolling this out. They proudly serve cities including Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, Mission Viejo, and the surrounding areas, too. They're already offering standard EV charger installation for both homes and businesses that maybe want to take that crucial first step towards getting V2G ready. Hashtag outro.
So to sort of synthesize what we've explored today, the future of urban energy, certainly here in Orange County, involves connecting individual EV battery storage directly to our public infrastructure. This shift really transforms cars from just being a liability on the grid or a simple load into a valuable asset. It helps reduce grid strain, supports California's clean energy mandates, and does it through localized, equitable solutions pioneered right here at the curbside.
Yeah, and that leads us to the final, maybe provocative thought we want to leave you with today. Considering this V2G future, a future where your electric vehicle could potentially operate as a mobile income source, actually earning you money during peak hours, how does that fundamentally change the math for you when thinking about owning and charging your car? It really shifts the economic calculation away from just cost minimization towards potential profit maximization. Something to think about. And if you are ready to explore the possibilities of installing an EV charger at your home or business right now, and you want a local expert who's already thinking about and preparing for this bi-directional future, Copperfield Electric offers installations serving the entire Orange County area with those EV installations starting at just $499. Thank you so much for joining us for this deep dive into the energy infrastructure of tomorrow happening today.